This video is about solving radical equations. And so if you have a worksheet, then the list of how to solve radical equations are listed. And if you don't, I'm just going to read them out so you'll know. It's a nice 4-step process. Number 1, isolate the radical expression on one side of the equation. So for instance, right here, this is the radical expression and it is isolated on one side of the equation. It's by itself on one side of the equation, and 5, which is not a radical, is on the other. Here, the radical expression is the square root of 2x. We have to get it by itself before we begin. That's what that means. Step number 2, raise each side of the equation to a power equal to the index of the radical and simplify. So, after you've isolated the radical expression, you're going to raise both sides of the equation to the power of the index, and that cancels out the radical. The index doesn't appear here, but we'll remember that when we don't see one, we know that that index is a 2. It's understood to be a 2. When we do see 1, 3, we know that the index is 3. If we saw 4 or 5, we know that be what the index is. 3, then you solve the equation for x. And then step 4, if, I'm going to change the steps from what it says on the sheet. If the index is even, you must, it's part of the process, check your answers. If the index is odd, you can check your answers, but that's just more of a feel-good, did I get the right answer sort of thing. It's not required as part of the process. When you have an even index, you have to check your answers, because when you square both sides of an equation, and that's what you do when you have an even index, or to the 4th, something even, you introduce many times extraneous solutions, which are solutions that look good, but they really do not solve the equation. They're false. So you have to know that by checking them, and it is required. It is part of the process. So here's a few examples of solving radical equations. Right here, we could solve this. Number 1, isolate the radical expression. It is isolated. Step number 2, raise both sides to the power of the index. The index is understood to be 2, so I'm going to square both sides. The square root of something squared, those cancel each other out. I'm left with just 3x minus 2 is equal to 5 squared, which is 25. Now I simply solve for x. I'm going to add 2 to both sides. I'm going to divide both sides by 3 to solve for x, and I get x is 9. Now, since the index was even, I have to check. This is really important. Here's my check. To do a check, you substitute the answer that you got into the original equation and see if you get a true statement. You're not trying to get the number 9 again. You're just trying to see, do I get something that is true? So, right here, I would say the square root of 3 times what I said I got, 9, minus 2. Does this really equal to 5? This is what we're asking ourselves. 3 times 9 is 27 minus 2. 27 minus 2 is 25. The square root of 25 is 5. I do, in fact, get 5. So there's my check, and this is a good answer. That is the full-blown process. Here's number 2. Let's go through it. Isolate the exponential expression. This right here is the exponential expression. So to isolate it, I will first subtract 4, which gives me negative 10. Then to get rid of this negative, I divide both sides by negative 1, and I get that the square root of 2x is equal to 10. Now, I'm ready for step 2. Raise both sides by the power of the index, or square both sides of this equation. The square root of something squared is just that something. 10 squared is 100. Divide both sides by 2. We get that x is 50. This is what we think our equation is, our solution is. We got to do the check. So let's do that real quick. Here's my check. Here's the check. You say, does negative, and you plug it in the original, does negative the square root of 2 times what we think our answer is, 50 plus 4 equal to negative 6? This is what we want to know. Does negative this plus 4 equal negative 6? Okay. Order of operations underneath here. This is negative times the square root of 100 plus 4. The square root of 100 is 10. 10 times negative 1 is negative 10 plus 4. This is negative 6. Is negative 6. That is correct. We get to keep this answer. All right. Let us do this one. Isolate the exponential expression. Add 3 to both sides. The cube root of 6x minus 3 is 3. Raise both sides to the power of the index. So this time I cube both sides. The cube root of something cubed is just the something. 6x minus 3 is 3 to the third power, which is 27. I'm going to add 3 to both sides. I get 6x is 30. I divide both sides by 6 and get x is 5. Now you can check this one to make sure you feel good about your answer, but you're not required to because as part of the process because no squaring took place. Real quick, let's do this one. Isolate your exponential expression. I'm going to add 2 to both sides. The cube root of 2x minus 3 is negative 3. When I add 2 to both sides, I get negative 3. I'm going to raise both sides to the power of the index. The cube root of something cubed is just the something. 2x minus 3 is equal to negative 3 times negative 3 times negative 3, which is negative 27. I'm going to add 3 to both sides. I get 2x is equal to negative 24 when I add 3 to both sides. Now I'll divide both sides by 2 and I get x is negative 12. That's my answer. I'm not required to check again here unless I just want to make sure that I didn't make a little math error, but it's not part of the process really when the index is odd, and it was odd, it was 3. So, but we could check this. We could say negative 12, let's put it in the original. 2 times negative 12 is negative 24, plus negative 3 is negative 27. The cube root of negative 27 is negative 3. Negative 3 plus negative 2 is negative 5. So that does check out. Okay, this last one, I'm going to change this because I want to do something real quick. Let's see. I'm going to change this last one. Let me do this one. Here's number 5. Let's say the square root of 2 times the square root of x minus 4 plus 6 is 8. Let's do this. Okay. So first thing to do is to isolate the exponential expression. Let me make this look a little bit neater. This is 2 times this. We need to isolate the square root of x minus 4. So let's subtract 6 from both sides. Is that right? No, I want to make this, I want to make this 4. All right. Let's subtract 6 from both sides. 2 times the square root of x minus 4 is equal to negative 2. Let's fully isolate the exponential by dividing both sides by 2. And so when we do that, we get the square root of x minus 4 is equal to negative 1. Raise both sides to the power of the index. So we're going to square both sides of this equation. Square root of something squared is just the something. X minus 4. Negative 1 times negative 1 is 1. We're going to add 4 to both sides and we get x is equal to 5. So we look like we're finished, but we also have to check because the index is even. So part of the process. So let's do the check real quick over here. If we do a check, we'll plug this answer into the original. So it looks like this. Does 2 times the square root of what we think our answer is, 5 minus 4 plus 6 equal to 4. This is what we're asking ourselves. Okay. 5 minus 4 is 1. The square root of 1 is 1. 2 times 1 is 2 plus 6 is 8. We find out that 8 does not equal to 4. This is an example of an extraneous solution that we got. We would at this point say, no, that does not check out. This is not a good answer. There is no solution to number 5. So sometimes that happens, and that's why they have that little step in there of why you have to check. Okay, that's solving radical equations.